Hello, this movie is for learning target 6, using angles of elevation and depression to solve problems. So what you'll need to know in this movie is that we're always going to go from the horizontal. So if we end up going from the horizontal up, that is going to be an angle of elevation. If we end up going from the horizontal down, that will be an angle of depression. So it's always from the horizontal. Suppose a person on the ground sees a hang glider at a 38-degree angle above a horizontal line. So the horizontal line would be your eyesight going horizontally, 38 degrees above it. That angle is called an angle of elevation. At the same time, a person in the hang glider sees the person on the ground at a 38-degree angle. So it's from the person's eyesight horizontally, that's this, down, that would be an angle of depression. Notice that the angle of elevation is concurrent to the angle of depression because they are alternate interior angles. Two horizontal lines are going to be parallel, so with this transversal, we get that alternate interior angles are congruent. You can use the angles of elevation and depression as acute angles of right triangles formed by horizontal distance and vertical height. Let's look at this. What is a description of the angle as it relates to the situation shown? For angle 1, for the bird, we're going from the horizontal down. So angle 1 is an angle of depression. From the horizontal down. Angle 4 goes from this horizontal up, so that's an angle of elevation. Angle 2 and angle 3, pause the movie, try those, and then press play when you finish. For angle 2, this person is going from the horizontal view up to see the bird. And so since they're going from the horizontal up, it's an angle of elevation. And 3 is from the horizontal down to see down here at the base of the cliff. Angle of depression. And we just did those two. So I'm moving on to this one. Here we have a person standing. Suppose you stand 53 feet from a wind farm turbine. Your angle of elevation, which would mean from your horizontal eyesight up, is 56.5 degrees. Your eye level is 5 feet above the ground. So this distance here is going to be 5.5 feet above the ground. Approximately how tall is the turbine from the ground to the hub? So we got to solve for this x value up here first. To do that, we've got this angle of elevation from our eyesight, 56.5 degrees. We're obviously going to stand there. X is our opposite side, 53 is our adjacent side. So the trig function that uses opposite and adjacent is tangent. So we take the tangent of 56.5, and that equals the opposite side, x, over our adjacent side, 53. We're going to solve this for x, so we're doing 53 times tangent of 56.5. Type that in, and we get about, 53 times tangent, 56.5, 80.07. is about x. Now, to get the height from the ground, you will notice that we have to add this part. So we're going to add 5.5 to get the total, and that's going to give us 85.574, which is about 85.6 feet tall. From the ground, because we had to include the eyesight, up to our eyesight. That's going to happen a lot when you set up this situation because you tend to go from your eyesight. Let's try another problem. You sight a rock climber on a cliff at a 32-degree angle. So from your eye level across, you go up, meaning your angle of elevation is 32 degrees. Your eye level is 6 feet above the ground. So what we know is that this is 6 feet above the ground. What is the approximate height of the rock climber from the ground? So we're going to solve for x, and then we're going to add these two together to get the height all the way from the ground. So if we're standing at the 32-degree angle, we have the opposite side and we have the adjacent side. So we use the tangent of 32 is equal to the opposite over the adjacent. And we type that in. We're going to multiply both sides by 1,000 times tangent of 32. And that equals 624.869. And I'm going to add the 6 feet. And we're going to get a total of 630.869. And we're going to round that to the nearest. What's the approximate height of the rock climber from the ground? Approximately 630.9 feet. We'll take it to the 10th. Approximately 630.9 feet. Again, remember, you're adding the height up to your eyesight for this. To approach a runway, 17 of the municipal airport in Oklahoma, the pilot must begin a 3-degree descent. Now, a descent is the angle of depression. It's going from the horizontal down. That's the angle of descent. And it's starting from a height of 2714 above sea level. So that's interesting to note. Above sea level, not to the ground. The airport is 1,007 feet above sea level. So what we've got is this sea level here, which is 2714, but we know that the airport, this part right here, is going to be 1,007 above sea level. What that does is we need to subtract to get what this length is right here. And that length right there is going to be 1,707 feet because we subtracted. So now that we've got this, we can form our right triangle here. This airplane's going at an angle of descent of 3 degrees. We know that all horizontal lines are parallel. So with these two lines being parallel, this will also be 3 degrees because they're alternate interior angles. Now you could also find what this angle is up here because this will equal 90. 90 minus 3 will give you 87. So we could use the 87 degrees, but we don't need to. And we're going to use this 3-degree angle. We're going to use the side length 1,707, and we need to find what x is. X is going to be, to the nearest tenth of a mile, how far from the runway is the airplane. So we are going to find this hypotenuse length. So we've got the opposite side. We want to find the hypotenuse. We're going to be using the sine. So the sine of 3 degrees is the opposite over hypotenuse, and we're going to solve for x, which means we're going to have to divide by sine of 3. And we get x is approximately, let's see what this is, divided by sine of 3. I've got 32616.199. And then it says to the nearest tenth of a mile. Now this is in feet. So we're going to have to divide that by 5,280 because there's 5,280 feet in a mile. And so that'll give us approximately, divided by 5,280, equals about 6.177, so 6.2 miles. And that's the answer to this question. Pause the movie, set up a picture for this one, and then press play when you're ready. So we got an airplane, sights a raft, that's my boat, at a 26-degree angle of depression. So that's going to go from the horizontal down is 26 degrees. The airplane's altitude, that would be from the perpendicular, is 3 kilometers. What is the airplane's horizontal distance, d, from the raft? Horizontal distance, d, from the raft would be this length. So we're solving for x here. So we set this up. We've got 26 is also here because of alternate interior angles congruent. And we're going to use the tangent function. So the tangent function of 26 is equal to 3 over x. We're going to solve for x, multiply by x, and then divide by tangent of 26. So we get that x is 3 over tangent of 26. .15, and this is that x is approximately 6.2 kilometers. That's our horizontal distance, and that's the end of this movie. Thanks for watching.